There's one other test that I'd like to show you in this section, and it's called the rational zero test. What this does, when it helps you find the zeros for a polynomial, um, it narrows it down for you. We'll use the rational zero test to narrow it down. We'll use synthetic division to make it exact. So when finding the zeros of a polynomial, the zero always has to have factors of the first or last coefficient. They can also be quotients of the factors. So here's how it works. We want to list all the possible zeros and then find what the actual zeros are. So the rational zero test says that I need to look at my last coefficient or constant and find all those factors. Well, the factors of 6 are 1 times 6 and 2 times 3, and they can be all positive or negative. Okay? Then it says I need to look at my first term. First term is a 1. Well, that's pretty easy. The factors of 1 are plus and minus 1. Okay? To find all the possible rational zeros, I have to divide the last by the first. So all these numbers up here get divided by all these numbers down here. So 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. So there's all my possible zeros. There's 8 of them. Okay. Now, if we didn't have calculators or a way to graph them, we would have to go through each one of these and do synthetic division and find out, okay, this one had a remainder of 0, that one's a factor. This one doesn't, so it's not a factor. We'd have to go through them all. So we're going to use synthetic division to find which one gives you a remainder of 0. We're going to start with 1. So I've got 1 as a coefficient here. I got 0x squared, so 1, 0, negative 7, negative 6. I'm going to start with 1. So 1 times 1 is 1, I add. 1 times 1 is 1, I add. And 1 times negative 6 is negative 6, and I add. I do not get a remainder of 0. So 1 is not a 0 of that function. So now we're going to try negative 1. I've got 1, 0, negative 7, negative 6. All right, so negative 1 times 1 is negative 1. We add. Negative 1 times 1, negative 1 is positive 1. We add. And negative 1 times negative 6 is positive 6. We add. I get a 0. So I know that negative 1 is a 0, and what's going to be a factor? Well, it's going to be a positive 1. X plus 1 would be a factor. Right? So x plus 1 is a factor, and I've got 1x squared minus x minus 6 left. And I can factor that. I know that my factors of negative 6 that add to give me a negative 1 are negative 3 and positive 2. So there's my factorization, and here are my zeros. So let's look at the next example. I need all my factors of 10. That's 1 times 10 and 2 times 5. All plus and minuses of them. I need my factors of 3. All of the factors plus and minuses. So I'm going to take this one, the last one's divided by the first. 1 divided by 1, 2 divided by 1, 5 divided by 1, 10 divided by 1. Then I got to come back and do 1 divided by 3, 2 divided by 3, 5 divided by 3, and 10 divided by 3. all of those plus and minuses. 2, 4, 6, 8, 10, 12, 14, 16 possible rational zeros. Now, we don't have time, literally, we don't have time in class to go through and find or shift through 16 possible numbers doing 16 different synthetic divisions. This is what your calculator is for, to help you. So what I would do if you were using your calculator to help you is you're going to type in this function to graph it. So we're going to use the calculator, graph that function, and look to find where does that graph cross the x-axis. And hopefully it's at a number you can determine. It's either at a whole number or a half or something like that. Okay? We're going to do that to get our first zero so we can start that synthetic division. So I think I graphed this one and it looked like it crossed at 2. And so I've got 3, negative 20, 23. And 10. And I'm going to try 2. And what should my remainder be? If 2 works, my remainder should be a 0. So I'll bring down my 3. 2 times 3 is 6. And I add. 2 times negative 14 is a negative 28. And I add. Get negative 5. 2 times negative 5 is negative 10. And I add, I get 0. So 2 is a 0. X minus 2 is a factor. So if I can get it down to a quadratic, I should be able to factor it. So here I'm looking for factors of negative 15 that add up to give me a negative 14. Okay, the bigger one's got to be a negative. So it's got to be a 1 and a negative 15, right? Come back through, divide by 3, it's simplified. Divide by 3, I get 5. Okay. So my zeros are 2, negative 1/3, and positive 5. Let's take a look at this one. Last digit is 3, so my factors are plus and minus 1, plus and minus 3. Coefficient of 1 on the first term, plus or minus 1. So I don't have very many to choose from. So we're going to try negative 1. So I've got factors, coefficients of 1, negative 6, 10, and negative 3. Make sure my signs are right. Oops. I got to add here. So that's going to be a 17. And negative 1 times 17 is 17. And that's going to leave me with a big remainder. So negative 1 doesn't work. But it says it should. Did I write down my numbers right? 1, negative 6. Didn't write down all the numbers. The second biggest mistakes teachers and students make, not writing down the problem correctly. All right, 1, negative 6, positive 6. 1. 10, negative 3. Let's try this again with the correct numbers. All right, bring down my 1. 1 times negative 1 is negative 1. We add, we get negative 7. That'll be a positive 7 here. If we multiply and we add, we get 13. And that'll be a negative here. We get negative 3. And we add. Now it works out good. All right, so negative 1 works. That means x plus 1 is a factor. And I have 1x cubed minus 7x squared plus 13x minus 3 remaining. Okay? It's not down to a quadratic yet. So I can do synthetic division again. Okay? I've tried negative 1. So the negative 1 is out. I only have 3 left to choose from. Let's try 3. But I want to use these coefficients now. We got a 1, a negative 7, a 13, a negative 3. Bring down my 1. 3 times 1 is 3. I add. 3 times negative 4 is negative 12. I add. And 1 times 3 is 3. I add. I get 0. So now I know x minus 3 is also a factor. And I've got my remainder here down to a quadratic. So now I should be able to factor that. Well, if you can't factor it, it doesn't work out. I don't have any factors of 1 that add up to give me a negative 4. The only factors of 1 are 1 times 1. 1 plus 1 doesn't add up to 4. So I have to use the quadratic formula. Remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're looking at standard form. So there's your a, your b, and your c's. So my a in this one is a 1. B is a negative 4. C is a 1. So I'll plug all those numbers in. And I get it down to 2 plus or minus the square root of 3. Well, how did I get there? The negative b is negative of negative 4. That's a positive 4. B squared minus 4ac worked out to be 12, but it's the square root. 12 simplified radical form is 2 root 3, because 4 times 3 is 12. One of those is a perfect square. So that's square root of 4 times square root of 3. That's 2 times root 3. Divided by 2. These go away, making a 2. These go away, and I'm left with 2 plus or minus square root of 3. So now my zeros are negative 1, 3, and 2 plus or minus 3. I've got 4 zeros. Potentially 4 zeros because of that digit. Possibly 4 zeros. This one turned out to be too real, too complex. Okay. Last one here. Factors of 8 right here. Factors of 6 right here. If I divide all those, I got 18 possible rational zeros. This is where you pick up your calculator and you graph the function and find out where it crosses the x-axis and start with that number. I've got 6, negative 1, negative 13, and 8. 6, negative 1, negative 13, and 8. We're going to start with 1. And we're going to see where that takes us. 1 times 6 is 6, we add. 1 times 5 is 5, we add. 1 times -8 is -8, and we add. So 1 is a 0. That means x minus 1 is a factor. And now I've got 6x squared plus 5x minus 8 left. Are there factors of -48 that add up to give me 5? No. So we have to use quadratic formula. My A is 6, my B is 5, my C is -8. Plug all those in, and I get an ugly complex number, but it works. So my factors, or excuse me, my real zeros are 1, and I've also got -5 plus or minus the square root of 217 divided by 12. So that's how we use the rational zeros test. All right, thank you for tuning in. Talk to you tomorrow.